As we know, we are here for Fortinet Firewall training. What we will learn in this training, what will be the procedure, what will be the structure of the content. First of all, let's discuss it. To know the content, you can go to I-MEDITA website, URL www.imedita.com. Go to live training, go to Fortinet FortiGate Firewall section. Here you will see the content which we will cover in this training. You can get this content by clicking on Get Browser. When you will click here, you can download the entire content, whatever we will cover in PDF format. You can keep it for your reference. Now, in this content or at this page, you will see course detail objectives. Here you will see summary points that what we will cover, and below it you will see that course outline detailed. Here you will see detailed information what we will cover in this training. So this will be the content which we will cover in this entire training. This entire training will be completed in 22 to 24 sessions. Approximately 22 to 24 sessions we need here. So what we will learn here in this detailed information, you can check here. Let's go with summary. First of all, we will learn here what is firewall. In this section, we will learn what is firewall, how many firewall techniques available in the market, like packet filtering, proxy server, stateful firewall, transparent firewall, and next generation firewall. After firewall and firewall techniques introduction, we will move toward next section. That next section is FortiGate introduction. Here we will learn about what are the features available in FortiGate firewall, how it is different from another firewalls like Palo Alto firewall and checkpoint firewalls or Cisco ASA. Here we will learn FortiGate firewall features as well as similarities and dissimilarities between or among another vendor devices. After it, we will learn in next section that will be here FortiGate lab setup and basics. In this section, we will learn how to set up lab at laptop or desktop so that we can do practicals. And in basics, whatever the resources required to set up lab, we will provide you all softwares, images, etc. And after setting up lab, we will learn here how to access firewall, how to enable telnet on firewall, how to enable SSH, HTTP, HTTPS, how to take a backup of the configuration, how to configure firewall in factory default format, how to restore configuration, how to upgrade firewall, how to perform password recovery. These things or tasks we will learn in basics. Whatever I have told you, the all things is mentioned here, that you will learn about firewall, FortiGate firewall. You will learn about lab setup and basics. Here we will learn how to access firewall, how to enable telnet, SSH, HTTP, HTTPS on firewall, how to verify connectivity, how to take backup of configuration, how to take plain backup, encrypted backup, how to perform factory reset on FortiGate firewall, how to restore configuration, how to reset admin password, and how to upgrade the firmware here. All these labs we will do. Entire training will be covered in two ways. First of all, we will do the things in GUI, and to do the things in advanced way, we will also use CLI. After basics, then we will move to basic routing. In basic routing, we will learn here how to configure IPv4 static routing, default routing, as well as we will also learn about link monitoring. What is link monitoring? Here I am expecting that you have knowledge of CCNA and CCNP. And when we go through with the content of CCNA and CCNP, at that time we learn about a feature or topic that is called SLA, Service Level Agreement. With the help of SLA, we can check reachability with the next hop device, or we can check reachability beyond next hop device. So that SLA, Service Level Agreement feature in FortiGate is called link monitoring. So we will learn it, what is link monitoring and how to deploy it. Next thing is here, zone implementation. FortiGate Firewall is a next generation firewall, and there are three leaders in firewall solutions: Fortinet, Palo Alto, and Checkpoint. When you talk about any firewall, it may be possible that someone will compare FortiGate with another vendor like Palo Alto and Checkpoint. Palo Alto Firewall and Checkpoint Firewall, they support a feature that is called zone. That is called here zone. Now they will ask you, if Palo Alto and Checkpoint support zone, does FortiGate support it? Then we will say yes. FortiGate Firewall also supports zone, and you can implement zone on FortiGate Firewall like Palo Alto and Checkpoint. After this, we will move toward advanced routing. In advanced routing, we will learn about RIP implementation and troubleshooting. And here in implementation, we will learn about basic RIP implementation, routing table verification, redistribution, timer modification, default information originate feature, as well as we will also learn how to change AD, how to deploy distribute list, how to deploy offset list, how to configure authentication and troubleshooting in your RIP protocol. So the features which are mentioned here, we will do practically on FortiGate Firewall. After RIP, we will learn here implementation and troubleshoot of OSPF. In OSPF, we will learn basics and multi-area implementation, neighbor table verification, database table verification, routing table verification. We will also learn how to deploy virtual link in OSPF, how to modify hello interval and dead interval, how to perform authentication, and how to configure stub area. After stub area, we will learn here how to configure totally stub area, how to configure totally NSSA area, how to perform external summarization, inter-area summarization, how to generate default route, how to perform redistribution, and along with troubleshooting. Then FortiGate also support along with OSPF another link state routing protocol, that is ISIS. In ISIS we will learn implementation and troubleshooting. Here we will learn about basics, neighbor table verification, database table verification, routing table verification, authentication, redistribution, and along with troubleshooting. After ISIS, we will learn here implementation and troubleshooting of BGP. In BGP, we will learn about basic implementation, neighbor table verification, BGP table verification, routing table verification. We will also go through with some attributes of BGP like next hop cell, route reflector client, authentication, aggregation, redistribution, as well as with the troubleshooting. So as we have learned here IPv4 routing, in same structure we will learn about IPv6 static routing, default routing, link monitoring. We will also learn about RIP-NG, implementation and troubleshooting, basic configurations, tables verification, redistributions, timer modification, default information originate, AD modification, distribute list, and offset list. In same way, we will learn about OSPF v3 with implementation and troubleshooting, with basic and multi-area configuration, with tables verification, with virtual links, timer modifications, with stub area, totally stub area, and totally NSSA area configuration, with external summarization, inter-area summarization, with default information originate, redistribute, and troubleshooting. In same way, we will learn ISIS routing protocol, and in same way we will learn here MP BGP multi-protocol border gateway protocol. So we will cover IPv4 and IPv6 routing. Next section we have here net security and net policies. Here we will learn what is network address translation, why we use net, and types of net available on FortiGate Firewall, with theoretical and practical, like what is static net, what is PAT, what is destination net, as well as with user authentication. In same way, we will also learn network address translation on IPv6, like static, like PAT, like destination net, and along with user authentication. After network address translation, we will move toward next topic, that is site-to-site VPN. Mostly, I think we are working professionals, or you are working professionals. You are working in any company. In your professional life, you have faced this problem that we have multiple branches connected to internet, and we want they should be able to communicate with each other, and they should be able to communicate with each other in a secure way. To do that, we configure VPN. Here, we will learn what is IPsec VPN and how to deploy it. So, site-to-site VPN is mostly used when we have two or more branches connected with each other and we want secure communication. For that, we deploy site to site. Let's understand it with the help of diagram. We have firewall 1 connected with ISP, firewall 2 connected with ISP, firewall lane, 1 lane and 2 lane. Now we want PC1 should be able to communicate with PC2. For that, we will configure IPsec VPN between these two firewalls, and with the help of IPsec VPN, users in branch 1 can communicate with user of branch 2 over internet in a secure way. So site-to-site VPN or IPsec VPN is configured between two branches or multiple branches. So here we will learn theoretical and practical. When we are talking about practicals, we will learn how to configure site-to-site VPN with IKE version 1 along with IKE version 2. When we configure VPN for authentication, we use two methods, pre-shared key or certificate. Here we will also learn how to configure site-to-site VPN with certificate authentication. When we will do implementation, definitely we will do some mistake, and to solve those problems or to shoot those mistakes, we will also learn what is the procedure, how we can come to know what is the problem and how we can solve it. We will also go through with troubleshooting. So these labs will be done FortiGate to FortiGate, but it is not possible that at every location we will get FortiGate firewall. We will also learn that how to configure site-to-site VPN, FortiGate to Cisco router, FortiGate to Cisco ASA, FortiGate firewall to Palo Alto firewall, FortiGate firewall to Checkpoint, FortiGate firewall to Juniper, FortiGate firewall to Cisco FTD, FortiGate firewall to Sophos firewall. So we will also learn here site-to-site VPN with FortiGate and another vendors. It is not possible that we can add every vendor, because here you can see there are lots of vendors available here in the list, but most of major vendors we devices we will include here for site to site VPN implementation. Next, we will also learn about site-to-site VPN implementation with IPv6. After site-to-site implementation and troubleshooting, we will move to our next section, that is firewall deployment. Here we will learn what is transparent firewall and how to configure it, how to configure site-to-site VPN in transparent firewall, and how to configure transparent firewall with IPv6. Now question is this, what is this transparent firewall? Let's understand it with the help of diagram. Here assume we have a location where we have PC as well as we have servers. They are connected. They are connected with switch. Switch is connected with router. Router can be connected with another router or branch with the help of leased line, that can be connected to another branch with the help of MPLS VPN, and it may be possible they are connected with each other via internet. So when we have connectivity between branches with leased line, with MPLS or with internet, then what we have connected at the edge of the network, we have connected here router. At this router, first of all, we will do IP addressing. Second, we'll do here routing. Next, we will do network address translation. We will also configure VPN. We will also configure here MPLS. Now, we have to secure this network. And we know to secure any network, we need to replace router with firewall. So we need to replace router with firewall so that we can protect our local area network. When we are replacing router with firewall, so what we need to do here? At firewall, we need to do IP addressing, we need to do routing, we need to do netting, we need to do VPN, and we also need to configure MPLS. But problem is this, firewall doesn't support MPLS. So MPLS we can't deploy here. And after this, we need to deploy firewall policies. Now, problem is this, MPLS is not supported, so we can't replace router with firewall. Then we have to place firewall behind router. So we need to place or configure firewall behind router. Then we need to connect it with the switch. So when we are adding firewall, again we need to do IP addressing on firewall, we need to do routing on firewall. But in this case, because firewall is behind the router, no need to configure netting, no need to configure VPN, no need to configure MPLS here, because MPLS is configured at the edge of the network. So when we are adding firewall, at least we have to configure IP addressing and routing. Then we have to configure policies here. But problem is this, we do not want to make any changes in our configuration, or we don't want to reconfigure our surrounding device. This is the problem. Or we can say here only we want firewall policies. So is there any solutions without doing any change? We can only deploy firewall policies. Yes, to do so, we have to use here transparent firewall. So we have to configure here transparent firewall. Transparent firewall is configured between lane and gateway. So we will deploy here transparent firewall, and it will work just like as a switch. So one interface we will connect with firewall. Second interface we will connect it at gateway. We will break the connectivity of gateway with LAN. Now traffic will pass through the firewall, and at this firewall, because firewall is acting as a L2 device, here we there is no need to configure anything. There is no need to configure any IP. There is no need to configure any MAC address. There is no need to do any changes in routing, IP addressing, netting, VPN, and plus nothing to do or nothing to change in lane side and gateway side, but only still you can deploy firewall policies in your network with the help of transparent firewall. So transparent firewall is only used when you want to deploy firewall policies in your lane without changing network. This is your transparent firewall. We will learn it along with IPv4 and IPv6. Next is here vWire deployment. So what is this vWire deployment? When we talk about firewall deployment, so firewall deployment, any vendor firewall, Cisco, Palo Alto, FortiGate, and Checkpoint, they can be deployed in L2 mode or they can be deployed in L3 mode. When we talk about L2 mode, we have two modes. First one is transparent mode, and actually three: bridge mode and virtual wire. When any vendor or any client is deploying firewall in L2 mode, we have three options: transparent firewall, bridge mode, and your vWire. These L2 modes available with different name in different firewalls. Like in Cisco firewall, you will get L2 mode with transparent mode. You will get L2 mode in with the name bridge mode checkpoint firewall, and you will get L2 mode with the name virtual wire on Palo Alto firewall. But when the things comes at the point of competition, now FortiGate says, okay, transparent mode solution is provided by Cisco. Then FortiGate says, yes, my firewall also support transparent mode. Virtual wire is provided by Palo Alto. Then FortiGate says, yes, my firewall also support virtual wire mode. Okay, so this bridge mode, or name the layer 2 mode solution with bridge mode, is only available in Checkpoint. So Checkpoint firewall provides L2 mode deployment only with bridge mode, while Cisco, FortiGate, and Palo Alto and FortiGate, they provide L2 mode with the name of transparent mode and vWire mode. So thing is same. Transparent mode and vWire both are L2 deployments, but different vendors support this L2 mode with the help of, or they do the marketing of this mode with the help of different names. So we will learn here both transparent as well as vWire. So transparent and vWire mode, both modes deployment we will learn here. Next we have here high availability. What is this? First of all, let's understand it with the help of diagram. We have a PC connected with switch. Switch is connected with firewall. Firewall is connected with outside switch, and then further it is connected with internet. Now there is a single point of failure at this link at firewall as at inside link. To solve this problem, what we can do? We can deploy here interface redundancy. In interface redundancy, we will get only interface redundancy, but at this firewall still we have single point of failure. To solve this single point of failure, all vendors firewalls support a feature or solution that is called failover or HA. With the help of high availability or failover, what we can do? We can group multiple firewalls together and we can treat them as a single firewall. This HA mode is available. HA is available in two modes like one is available active and passive. In active passive, one firewall will remain primary, another remains secondary. So first primary firewall will forward the traffic. If primary firewall will work as active, secondary firewall will work as passive. So first of all, traffic will go via primary. If your primary firewall will goes down, then secondary firewall will promote itself as primary and that will become active. Now the traffic will go via new active. In active passive, only one firewall forwards the traffic at a time. But there is also another mode available in HA, that is active active. In active active, both firewalls remain active and they process the traffic. So with the help of HA, what we do? We group multiple firewalls together. We treat them as a single device. And if one firewall goes down, then in HA, another firewall is available to forward the traffic. So this feature is called HA or failover. FortiGate firewalls support active passive and active active HA or failover, and it also support IP version 4 as well as it also support IP version 6. So we will learn here both active passive HA of IPv4 and IPv6, active passive and active active with IPv4 and IPv6 addressing we will learn here. Next feature is here SLB, server load balancing. What is this server load balancing? This server load balancing feature is only available in FortiGate firewall. It is not available on Cisco ASA. It is not available on Cisco FTD. It is not available on Palo Alto. Not available in Checkpoint. This feature or solution is only available in FortiGate firewall. What is this? Let's understand it. With the help of diagram, we are talking about SLB, which is actually server load balancing. With the help of server load balancing, what we can do? Assume we have a server here connected with firewall, connect, or we can say it is connected with firewall, then firewall is connected with internet, and at internet users will, because here in lane what we will use here, we will use private IP. At internet what we will use here, public IP. So with the help of network address translation, first of all, let's forget about SLB. With the help of net, we can map 192.168.101.100 IP with this public IP, that if anyone will hit this public IP, they can access this server. But we know that all servers have connection limitation. We are assuming that this server can handle only 10,000 connections. So it means only 10,000 users can get the service. But when we say users will be approximate 40,000, then this single server can't provide or handle those connections. So netting will not solve this problem. To solve this problem, we will take the help of here SLB, server load balancing. In server load balancing, what we will do? We will not deploy only one server. We will deploy here multiple servers like server 1, server 2, server 3, and server 4, and we are assuming that all servers can handle, individual server can handle 10,000 connections. So what we will do with the help of server load balancing? Here, with the help of server load balancing, we will define if anyone will hit this public IP, that traffic will be distributed to server 1, server 2, server 3, and server 4. So with the help of server load balancing, we can distribute the load to backend servers based on different load balancing algorithms. You can use here round robin, you can use here weighted. So what will happen in round robin and what will happen in weighted, we will learn at the time of SLB, but here it is just because it is our first class, and here we are just going through that what we will cover in this training. So it is just intro or just a brief intro that what is SLB. With the help of SLB, server load balancing, our FortiGate can distribute the traffic, or we can say here FortiGate can distribute the traffic or load to multiple backend servers with the help of different load balancing algorithms. So this thing can also be done by FortiGate Firewall. Next, we have here admin profile. So what is this admin profile? Normally, when we access FortiGate Firewall, we can configure everything. For example, we have here FortiGate Firewall that is connected with our lane. In lane, there are two admins. We can define this is our, for example, admin 1, this is our admin 2. So both admins can access the firewall and they can configure it. But we know this admin 1 is just fresher and admin 2 is experienced. So we can create here profiles for both admins that this admin 1 can only do read only. It can only read the configuration, but it can't configure anything because it is fresher. Admin 1 is fresher, but another side, admin 2 is an experienced candidate. He or she has knowledge that how to configure the things. So we can provide right to admin 2 that he or she can do read and write, means along with reading the configuration, this admin 2 can also configure something. So this configuration, you can configuration right, that what he or she can configure, you can define with the help of profiles or with the help of admin profiles. How to deploy it, we will learn practically here. Next, we have here VRRP, Virtual Router Redundancy Protocol. What is VRRP? Before understanding it, let's go through with the diagram. We have lane. In lane, we have here some users. They are connected with switch. In this way, we can connect with switch. Switch is connected with firewall 1 and here firewall 2. Both firewalls are connected with ISP1 and ISP2 in this way. Now, at these firewalls in lane interface, we will configure IP. Any IP like 192.168.101.11, 192.168.101.12. Now question is this, what will be the gateway for these clients? If we say your gateway is 11, then all the traffic will go via firewall 1. If firewall 1 will goes down, they will not be able to go to outside. Then we have to manually change the gateway from 11 to 12. So we need to configure the gateway 12. Same problem. If this firewall will goes down, the clients who have gateway 12, they can't go to outside. To solve this problem, we use a protocol. That protocol is VRRP, Virtual Router Redundancy Protocol. With the help of VRRP, we will create a virtual IP here like 192.168.101.1. Same virtual IP we will configure at firewall to 101.1. With this help of virtual IP or with the help of VRRP, we will say to firewall 1 that for this IP, you will be primary or you will be the master, and firewall 2, you will remain backup for this IP. Now, this IP will be the gateway for all the clients. All the clients will use this IP address as gateway, and for this IP, who is the master? Firewall 1 is the master. Now, firewall 1 is responsible for this IP and it is responsible to send traffic in to out or out to in. Now, what will happen if firewall 1 will goes down? If firewall 1 will goes down, then this backup device or backup firewall will promote itself as a master. Now, automatically, all the traffic which was going toward firewall 1, that will be automatically redirected to new master, which is firewall 2. Now, firewall 2 is responsible to forward the traffic into out or out to in. Now, what we are achieving here, this IP is our gateway, and here we are getting gateway redundancy. So with the help of VRRP, we can provide gateway redundancy on FortiGate firewall. Just like VRRP, there are also another protocol like HSRP and GLBP, but these protocols are Cisco proprietary. They are not supported on FortiGate firewall. VRRP is open standard protocol which is supported on FortiGate. So these all HSRP, VRRP and GLBP, they provides us gateway redundancy. Because these are Cisco proprietary, we can't deploy them on FortiGate. VRRP open standard and it is supported by FortiGate. We can deploy it, and with the help of VRRP, we can provide gateway redundancy to our client. So this thing we will learn theoretical and practical on FortiGate firewall. Next, we have here ADVPN, Auto Discovery VPN. What is this? Before ADVPN, we have discussed here about site-to-site VPN. So site-to-site VPN is point-to-point VPN. And what is then ADVPN? Now let's understand it. What is ADVPN? Assume we have here two branches. Now we have firewall 1 connected with ISP, then we have firewall 2, then we have firewall 3, then we have firewall 4. In this way, you can assume we have multiple firewalls. Now we want they should be able to communicate with each other. Which kind of VPN we have to deploy here? For secure communication, we have to configure here site-to-site VPN. So site-to-site VPN is actually point-to-point VPN. But here we want a full mesh VPN. Full mesh VPN is ADVPN. Now, instead of site-to-site VPN, we will deploy here ADVPN, Auto Discovery VPN. In ADVPN, we configure one hub, another we configure as spoke. First of all, each spoke in ADVPN, each spoke will register itself as hub and they will create a static tunnel. They will create a static tunnel. But when one spoke wants to communicate with another spoke, they will create dynamic tunnel automatically. So when one spoke wants to communicate with another spoke, they will communicate with each other with the help of dynamic tunnel, and this dynamic tunnel will create automatic. No need to configure it. So what is ADVPN? With the help of ADVPN, we can create here full mesh VPN on FortiGate Firewall. But limitation is this: all devices must be or must belongs to FortiGate. You can configure ADVPN only on FortiGate firewalls. If these devices belongs to different vendors, then we can't configure ADVPN. At that time, we have only one solution, that is side to side. But if you have all devices belongs to FortiGate and you want to configure a full mesh VPN with easy configuration, then you can deploy ADVPN. Done. So this will be our ADVPN here. Next, we have here dial-up VPN. So what is dial-up VPN? Let's understand it with the help of diagram. Assume we have internet user or a remote user. We have internet connected with FortiGate firewall. FortiGate firewall is connected with inside network like switch, and switch is connected with servers. Now we have a remote user connected to internet. This remote user has public IP like 102.1.100, 102.1.1.1, 101.1.1.1, 101.1.100. In private lane, we can use here private IP 192.168.101.1, 192.168, 101.100, 192.168.101.200. Now this remote user want to access internal resources of a company using its PC. The user will generate a packet like 102.1.100 and destination IP will be here 192.168.101.100. Such kind of packet will go to internet. Internet will check destination IP, which is private. Internet has only public IP information. The packet will be dropped by internet. Packet will not go to actual destination. Normally, this remote user can't access internal resources. Now, how we can access it? To access it, we will deploy dial-up VPN here. So a VPN will be configured between PC and firewall. With this VPN tunnel, or user will establish a VPN tunnel with FortiGate firewall, and using this tunnel, this remote user can communicate with internal resources of a company. This VPN solution is called dial-up VPN, or we can call it remote access VPN. So what is dial-up VPN or remote access VPN? Dial-up VPN or remote access VPN enables a remote user that they can access the internal network of a company in a secure way over internet. So this is your dial-up VPN. When we use IPsec here, that is called IPsec remote access VPN, or you can call it dial-up VPN, or you can call it IPsec remote access VPN. Same function can be achieved with the help of SSL VPN here. So You can also do the same thing with the help of SSL VPN. So we can say here that remote access VPN can be deployed with the help of IPsec or can be deployed with the help of SSL VPN. When we are using IPsec, it is called IPsec RA or it is called dial-up VPN. So this thing should be clear. For remote access VPN, we can use IPsec or SSL. When we are using IPsec, it is called dial-up VPN. Or when we are using SSL protocol, then it is called SSL VPN. So both are the same thing, but only the difference is dial-up VPN use IPsec protocol, SSL VPN use SSL protocol for secure communication, and both provides same result. Next, we have here SD-WAN, software defined wide area network. What is this SD-WAN? Let's understand it with the help of diagram. So we have here users like PC1, PC2, 3 and 4. They are connected with switch. Switch is connected with firewall, and it may be possible that this firewall is connected with multiple ISPs. Now, what is SD-WAN? FortiGate says that SD-WAN is a virtual interface in which we group multiple member interfaces. So SD-WAN is a virtual interface, and in that virtual interface we can group multiple physical interfaces, and we can group up to 250 member interface in a single SD-WAN virtual interface. Then what is the advantage of grouping multiple member interface in a single virtual interface? When we are grouping multiple member interfaces, then here we need to configure only one route for these interface, and we need to configure one policy for these interface. One route we need to configure, one policy we need to configure, and that route or policy will apply on all member interface. So what we are achieving here, SD-WAN is an approach. Using it we can distribute internet bound traffic on multiple links, and to do so we need to group them. When we will group multiple physical interface in a single virtual interface, that is actually SD-WAN interface, and we can group up to 250 member interfaces here, and you can utilize all these links in a better way. So this is your SD-WAN or Fortinet software defined wide area network. Next, we have here FSSO, Fortinet single sign-on. What is this? Fortinet single sign-on, we can understand it with the help of diagram. Assume we have here PC, connected with switch, connected with FortiGate, connected with internet. Normally, when we will define policy on FortiGate firewall, then policy structure like this. Policy structure will be like this: source, destination, and we can say here source, destination, and action. Like 192.168.101.0, this is the network. Destination, if it wants to go anywhere, then what we will do? Allow. Normally, when we create policy on FortiGate, in policy we define IP address. But we want to enable here more control. For that, we have Microsoft AD, Microsoft Active Directory in our organization. That Microsoft AD has groups like HR, like IT, like sales. Now, we want on FortiGate that we should configure policy in such way if user belongs to HR, IT or sales, only they can access to internet. For that, we need to do the integration of Microsoft AD with FortiGate Firewall, and that integration is called here FSSO, Fortinet Single Sign-On. Fortinet Single Sign-On is a solution. Using it, we can integrate Microsoft Active Directory with FortiGate Firewall so that we can synchronize AD groups with firewall. And when groups will be synchronized, AD groups will be synchronized on firewall, then we can configure policy in this way that if the user belongs to HR, user belongs to IT, user belongs to sale, if they want to go anywhere, they are allowed. Done. So with the help of SSSO, we can integrate Microsoft Active Directory with FortiGate Firewall so that we can deploy AD's group base policy on FortiGate Firewall. If you want to deploy AD's group-based policy on FortiGate, you need to do integration. That integration will be done with the help of FSSO, Fortinet Single Sign-On. So this is our FSSO. Next, we have here virtual domain. What is this virtual domain? This virtual domain, let's understand with the help of diagram. Assume we have a web hosting company. In web hosting company, the customers can store their or customer can deploy their servers. Now customers are demanding that our server should be protected by a dedicated firewall. Now we have 4 customers. To fulfill the requirement of 4 customers, we need to purchase 4 firewall. These 4 firewalls will be costly. So all vendors provides a solution that there is no need to purchase multiple physical firewall. You can purchase a single physical firewall, and in that single physical firewall, you can create virtual firewalls. These virtual firewalls are called VDOM, or they are called VSX, or they are called VSys, or they are called security context. So what is VDOM now? VDOM is actually virtual firewall within a single physical firewall. Same solution is also provided by another vendors. This virtual firewall is called VDOM by FortiGate. It is called VSX by Checkpoint. It is called VSys by Palo Alto. It is called Security Context by Cisco. So all vendors provides virtual firewall solution in a single physical firewall, and that virtual firewall is called VDOM, VSX or VSys or security context. Clear? So this is our VDOM. We will also learn about it. Next, we have here interface redundancy solutions on FortiGate Firewall. FortiGate provides two interface redundancy solutions like Ether channel and redundant interface. For example, assume we have four interfaces on a FortiGate firewall, like port number 1, 2, 3, 4, or we can say here we have a FortiGate. It has four interfaces. Now we are only utilizing two interfaces. One is connected with inside and another is connected with internet. Still, we have two unused. We have 1, 2, 3, and 4. We are using only two. Do we have only any option using which we can get interface redundancy? Yes. Then FortiGate says if you have manageable device like switch, then you can bundle physical interface and you can create here ether channel. So ether channel you can create when your opposite device support ether channel, and we know that in switches we have a feature that is called ether channel, and using ether channel we can bundle switch interfaces. Same technology or concept is also supported by FortiGate firewall. On FortiGate you can also bundle FortiGate interface in a logical interface, and you can treat them as a single interface. But limitation is this: when we have opposite device, manageable device, or we can see here we have device which is manageable, only we can create ether channel. What will happen if we do not have switch opposite side, we have a device like hub, then can we still get interface redundancy? Yes. FortiGate says if opposite device is not manageable, that is a unmanageable device, still you can do interface redundancy. You can bundle them, and that is called redundant interface. Done. So FortiGate firewall support two solutions for interface redundancy. One is ether channel. If your opposite device support it, you can configure ether channel. If opposite device is not manageable like hub, still you can configure or you can bundle interface with the help of redundant interface. When you will use a redundant interface, one interface will be primary, that will work as a primary interface. Another will work as a secondary. When primary will goes down, firewall will use secondary interface. In redundant interface, only one interface will be used here. In ether channel, we can bundle maximum 8 links, and both all links will be used simultaneously by the switch as well as by the FortiGate to forward the traffic. So these two features are also supported by FortiGate. Next, what we have? Next, we have here centralized logging device analyzer and centralized management device like Forti Manager. You have 2 or 3 options using which you can configure the firewall. Like you can access the firewall via telnet, via SSH, or via console in CLI format. You can also access via firewall via browser with the help of HTTP or with the help of HTTPS using your PC. But if you have multiple firewalls, then you can use a centralized management server provided by FortiGate. So that is called FMG Forti Manager. You can use Forti Manager to manage multiple FortiGate firewalls. Okay. Using a single device, you can manage multiple FortiGate firewall of your multiple locations, as well as You can also use a device that is called FAZ40 analyzer. FAZ40 analyzer. 40 analyzer is a centralized device which can be used for to store the logs at a central location. So manager is used to manage FortiGate firewall, FMZ to manage multiple FortiGate firewalls, and analyzer is used to collect logs of multiple FortiGate firewalls on a single device. Okay, so we will also learn how to manage firewall via Forti Manager or how to send logs on Forti Analyzer. We will also learn these things. Next, we have here certificate operations or SSL decryption. What is this? To understand it, let's go through with the diagram. Here we have a scenario that we have a PC connected with firewall. Firewall is connected with internet, and this internet is connected with a server. Server belongs to HTTPS. At this firewall, what we will do, we will allow here HTTPS. Using HTTPS or using policy, this client will establish tunnel, or this client will establish SSL or HTTPS tunnel with server through firewall. So there will be a SSL or HTTPS, or we can say TLS tunnel. Using this tunnel, your client can communicate with the server in a secure way. But along with secure communication, this user can also do malicious activities, like user can download virus exchange, spyware exchange, file exchange, or there can be data loss with the help of this tunnel. Now we want that our firewall should be capable to see that what is going under the SSL tunnel, and if something is suspicious, let's block it, only allow secure communication. To do so, your firewall should have capability of decryption, SSL decryption, or HTTPS inspection. So with the help of HTTPS inspection or SSL decryption, with the help of HTTPS inspection or SSL decryption, our firewall can look inside SSL tunnel, and if something is suspicious, we can block it. But remember it, decryption can only look, or we can say can look, or it can read what is going, under SSL tunnel, but it can't drop it. To drop it or to block it, we have to use another features that is called security profiles. So we need to enable security profiles, and with the help of security profiles, we will use here security profiles like antivirus, application control, file filter, web filter. So with the help of security profile, we can block virus, spyware, file, or we can also block here data loss. But remember it, with the help of HTTPS inspection, our firewall can only look or read what is going under SSL tunnel or what is going under SSL session. If we have enabled security profile, we can also block virus, spyware, file, as well as data loss. So security profile can work under SSL or work for SSL traffic as well if we have enabled HTTPS inspection or SSL decryption. So this feature is only available in next generation firewall. It is not available on normal firewall. Only next generation firewalls like Palo Alto firewall, FortiGate firewall, Checkpoint firewall, Cisco FTD, they can see what is going under SSL tunnel. And if you have enabled security profiles or blades, security blades, you can block that. Now question is this will work in this way? No. Detailed theory we will do at the time of when the decryption topic will come. Here it is only just introduction that with the help of HTTPS inspection or decryption, we can look or read what is going under SSL tunnel. If something is suspicious, we can block that with the help of security profiles. Next, we have here, because you have also deployed decryption, you can see what is going there. And to protect your network, we can deploy here application control profile. You can also deploy security profiles like application control, antivirus. You can also deploy file filtering. You can also deploy web filtering, that with the help of application control, you can control the applications which are going to happen or going to establish between client and server. For example, let's understand here application control profile. For example, let's take the help of diagram here. We have a client connected with server. Now, this client has established, client is using dynamic port number. It is hitting to the port number 443. Under the port number 443, they are using SSL tunnel. Under SSL, they are using another applications. For example, let me use some colors here. So this FortiGate firewall and identify. Okay, first we have here SSL tunnel. Under SSL, we are using here Facebook. Then we are using here like chat. Okay. Or we are using here like post. So with the help of application control profile, we can control these applications, that it should be allowed, this should be blocked, like we can do with the help of application control profile. But remember it, this will work perfectly if you have configured decryption. If you have not configured decryption, then firewall will not be able to identify that what is going under the SSL tunnel. So for that, you have to enable decryption. Only then you can identify as well as you can control these applications. Next, if you will use here antivirus profile, or if you will enable antivirus profile, you can block the virus when they are trying to enter in your organization. With the help of file filtering profile, you can block, for example, exe file, you can block PDF file, or you can generate log for these files. You have web filtering profile. Using web filtering, you can configure here URL filtering, that which website is allowed in your organization, which is not. So you can also deploy security profiles on FortiGate firewall. We will learn about them. Next, we have here packet, life of packet, or here we will discuss about packet flow on FortiGate firewall. So this will be our content, which we will cover in our entire training. And this entire training will take about 22 to 24 sessions. Okay. And sequence is in front of you. So this is just introduction, what we will cover. If you have any question, we can discuss. If not, then we will start firewall introduction tomorrow. Today only this one. Any question from your side? same time.
I'm having one question, not related with the course outline and details. I want to know the FortiGate certification path, and after this completion this course, we are eligible for which certificate? Can we get that?
This this course or this content will cover the content or topics of two courses which is provided by FortiGate, and these two courses are FortiGate Administrator and FortiGate Immersion. Okay, so this is the content of Administrator and Immersion. You can see here that system setting, netting, routing, etc. And another you will see here SSL, IPsec, equal cost, like this. So not everything. This is a combined course and which will give you related knowledge of these two certifications. Okay,
Okay, okay, okay.
but
So,
in so this is if you say that which everything will be covered, no. So that's why in the beginning, this will be the content which we will cover in this entire training, which will match with these two courses. In previous class, yesterday we completed till course content introduction. Now let's start with firewall introduction. Now question is here, what is firewall? As I told you yesterday, that if you want to learn the firewall, at least you should have the knowledge of CCNA and CCNP, then you can understand it in better way. Now, if someone asks us that what is firewall, then we can tell him that firewall is a system or group of systems that manage access between two or more network. Now let's understand it. Suppose we have a PC connected with router. Router is connected with another router, and that router is connected with LAN like this. Also mention IP addressing for easy understanding. 192.168.101.100, 192.168.101.1, 192.168.1.1, 192.168.1.2, 192.168.102.1, 192.168.102.100. Now, if we will configure here IP addressing and routing, we can make it possible that PC1 can communicate with PC2 and PC2 can communicate with PC1. This will happen after IP addressing and routing. Now, our requirement is this: PC1 should be able to communicate with PC2, but PC2 should not be able to communicate with PC1. To obtain this functionality or this result, we have to use firewall, and this firewall will be deployed at the place of router. You can use single system. For redundancy, you can use two, one primary, another secondary, and you can configure them in HA high availability or failover. Now at this firewall, we will define policy. At this firewall, we will define here policy like if the source network is 192.168.101.0 and destination network is 192.168.102.0, then action should be allowed. Like this, we need to define policy on this firewall. Now we can say that firewall is a system. You can use a single system, or firewall can be a group of system that manage access between two or more network, we have one network 101, another network 102, and this firewall will define who can access which one. So we can simply say here, firewall is a system or group of system that manage access between two or more network. Firewall can be hardware. Yes, when you are replacing a router with a firewall, at that time, firewall will be available in hardware format. Firewall can be software. When we install antivirus at PC or when we install antivirus at server, then that is also called firewall by some people, because that software control the traffic which is going out or which is coming in on those machines. So firewall formats can be hardware or it can be software. Software when we are using antivirus, as well as firewall can be in the format of virtual appliance in present time. So before understanding virtual appliance, this thing should be clear that firewall is a system or group of system that manage access between two or more network. It can be hardware, it can be software. Now we have to understand when or in which situation firewall can be in virtual appliance format. To understand it, we know that in present time we use cloud solutions. Cloud solutions, we use two types. One is public cloud, one is public cloud, another is private cloud. In public cloud, we have Amazon Web Services, Microsoft Azure, Google Cloud Platform. On these cloud platform, we can deploy a server here. And to protect that virtual server, we need to use here virtual appliance. In private cloud, we can use VMware workstation. We can use here VirtualBox. And on these private cloud, we can also deploy virtual servers, and to protect those virtual servers we have to use here virtual appliance. So virtual appliance is available for public cloud as well as for private cloud. Now this thing should be clear, what is firewall and its format. After knowing firewall, let's move to next topic, that is how many techniques or how many firewall techniques available in the market. There are multiple techniques available in the market like packet filtering, proxy server, stateful firewall, transparent firewall, and next generation firewall. Let's start with packet filtering. What is stateless packet filtering or packet filtering? So we can say in stateless packet filtering or packet filtering, packets are filtered with the help of ACL, access control list. In stateless packet filtering, packet can be filtered based on layer 3 to layer 7 of OSI model. If you want to filter the traffic from layer 3 to layer 7, you can use access list. When we are using access list, that is called stateless packet filtering. There are multiple types of access list available like standard access list, extended access list, named access list, time-based access list, as well as there are some others. ACLs are also available, dynamic access list, reflexive access list, and TCP established access list. These types of access list can be implemented on router to protect your network. When we are using access list, definitely we will get some advantages. So first advantage is here easy to implement. How we can say it is easy to implement? We can say it is easy to implement like when we have a PC connected with router, connected with server. Now, router interface 0 by 0, 0 by 1. If PC is the source, server is the destination. Traffic will in at interface 0 by 0. It will out from 0 by 1. If the server belongs to HTTPS, then at in or out direction, we need to create ACL. In ACL, we need to allow something like we need to allow HTTPS. HTTPS use TCP port number 443. So we need to allow here, we need to allow TCP port number 443. We need to allow. If the server belongs to HTTP, then we need to enable here, or we need to allow TCP port number here 80. Okay. If the server belongs to SMTP, then we need to enable TCP port number 25. So we need to create an ACL. In ACL, we need to allow these ports, and after allowing these ports, we can implement it at the in direction or at out direction. If we know the port number of the application, then we can say it is easy to implement. Next advantage is cost effective. How we can say ACL deployment is cost effective? ACL can be created on switch, can be created on router. If your infrastructure device, switches or routers support ACL configuration, then there is no need to purchase any additional device. And if we are not doing any investment, or if we are not purchasing anything, our existing infrastructure support it, then we can say it will be cost effective for the organization. So packet filtering has advantages, easy to implement and cost effective. Along with advantages, it also has some disadvantages, like it is not scalable. In disadvantage, it is not scalable. And next disadvantage is complex access lists are hard to create and maintain. So what is the meaning of these lines? These lines say, first says that not scalable. If we have like 10, 100 source, 10 destination and 10 services. Now we want to know that how many ACL entries we need to create. Formula is multiply source with destination, then multiply with services. 100 multiply with 10,000, 1,000 multiply with 10, then we can say here 10,000. So if we need to create ACL for 100 source, 10 destination, 10 services, so we need to create here 10,000 entries. The job of creating 10,000 entries is not easy job, so we can say it is not scalable. Next disadvantage is here. Complex access lists are hard to create and maintain. What is the meaning of this line? This line, we have a PC connected with router connected with internet, and internet is connected with a server, that is our DNS server. So what we need to do? We need to create a rule on router that allow UDP port number 53. This kind of rule we need to create at router. Now there is a user in our lane. That user will send DNS query that will be encapsulated under UDP 53 along according to rule. Yes, that query is allow. But assume at internet we have a torrent server. Now we have another user that will encapsulate torrent data under UDP port number 53 according to ACL. This is also allowed. Now we can't create such ACL on router that if traffic contain or packet contain DNS query under 53, only allow it. If the packet doesn't contain DNS under 53, don't allow it. This kind of job cannot be done by packet filtering. So this is the disadvantage. This is the disadvantage. Whatever you will allow, if you have allowed any port like 53, at that 53 port number, DNS is also allowed, as well as your torrent is also allowed. So this is the drawback of packet filtering here. After this technique or method, we have next technique available in firewall, that is proxy server. Let's understand proxy server with the help of diagram here. So we have a PC here, like user connected with user, that is connected with router, and router is connected with PC with router. Then we have internet, and at internet we have here two public servers. For example, first one is here Google, and second one is, for example, YouTube. Now the user which is in our premise that can access Google, as well as that can also access YouTube. Now we want user should not be able to access YouTube. For that, we need to deploy a solution that is called proxy server. In the lane, we will connect our proxy server. At proxy server, we will define policies. In policies, we will say here, like, if someone want to access Google, that should be allow. If anyone want to access YouTube, that should be deny. Such kind of policies we will implement at our proxy server. Now we need to send traffic to proxy server. So we can send traffic to proxy server using two ways. So first method is here explicit proxy. Second method to send traffic to proxy server is transparent proxy. So let's take the example of explicit proxy. In explicit proxy, we will configure the client, or in explicit proxy, we need to do client configuration. We will tell that you need to send the traffic to proxy server. So if you are or we are using explicit proxy, in that condition, client will send request to proxy server that I want to communicate with Google. That traffic will come here. Then proxy server will check the policies that Google is allowed. Now in third step, proxy server will send request. Proxy server will send request to Google, and Google will give reply to proxy, and then proxy server will send reply to client. Now client can access Google. But if client will say, I want to communicate with YouTube, request will come at proxy. Proxy will check the policy that YouTube is not allowed. In third step, proxy will give reply to client that YouTube access is equal to deny. You can't access YouTube. So you can see, or we can see, in explicit proxy, we need to do client configuration. And when we are doing client configuration, client will send request to proxy. Proxy will check the policy. If URL is allowed, proxy will send request to internet. Internet will give reply to proxy. Proxy will give reply to client. If URL is allow, request is allow. If URL is deny according to the policy, then user can't access those URLs or servers. This will happen in explicit proxy. Next method or deployment method of proxy server is transparent proxy. In transparent proxy, we need to do gateway configuration. At gateway, we define that you have to send request to proxy server. Now, what will happen? Simple. Client will send request to gateway that I want to communicate with Google. Now, this gateway will send request to proxy server. That request will be redirected to proxy server. Now, in third step, proxy server will check the policy. Google is allow. Now, this proxy server will send request to Google, and in fifth step, Google will send reply to proxy, and then proxy will give that reply to your client in this way. So there are two methods using which you can deploy proxy server in your lane. First one is here, explicit proxy. In explicit proxy, client will send request to proxy server. Next method is transparent proxy. In transparent proxy, client will send request to gateway, gateway will send request to proxies. Either client will send request to proxy or gateway will send request to proxy. Ultimately, request will come at proxy, proxy will send it to internet, internet will give reply to proxy, then proxy will give reply to client. So this proxy server is working as an intermediate system. So same thing is mentioned here, that what is proxy server? Proxy server works as an intermediate system between inside and outside world. Proxy server will not allow inside users to go outside directly or vice versa. Proxy server is also called application gateway or application firewall. Proxy server is mostly used for URL filtering. URL stand for Universal Resource Locator, also known as Uniform Resource Locator. There can be limitations when we are using proxy server. First is single point of failure. Second one, it introduced delay. To overcome the problem of single point of failure, we can use HA here, one primary, another secondary. If primary goes down, secondary is responsible to provide services. So single point of failure can also be solved, but it introduced delay. We can't finish delay because client will send request to proxy. Proxy, either primary or secondary, will send request to internet. Internet will give reply to proxy, then proxy will give reply to client. Definitely there will be delay in millisecond. We can't do anything related to delay, but yes, single point of failure can be solved. So this is something about what is proxy server, how we can deploy it, and advantage or limitations are in front of you. Next, we have here another firewall technique, that is stateful firewall. To understand it, let's go through with diagram here. We have a PC. We are talking about stateful firewall. In stateful firewall, we have a PC connected with a firewall, that is your stateful firewall, and that firewall is next connected to server. For easy understanding, we can mention IP address like 192.168.101.100, 192.168.102.100. Client will use dynamic port number. It will hit to the well-known port number of server like HTTPS. Now, first of all, this PC will generate a packet. So a packet will be generated by PC. Packet structure will be like this. Source IP will be here. Source IP 192.168.101.100. Destination IP 192.168.102.100. Source port 1025. Destination port 443. It is TCP first packet, then TCP flag. We can mention here TCP flag SYN request. Such kind of packet will be generated by PC. This packet will be sent to firewall. In third step, this firewall, or we can say stateful firewall, will create a database like who is coming, source IP 192.168.101.100 is going to 192.168.102.100. Source port 1025 is going to 443. TCP flag is SYN. Such kind of database will be created by stateful firewall. Then this packet, in fourth step, this packet will be forwarded to server. Now this server will give reply like source IP 192.168.102.100, then destination IP reverse 192.168.101.100, 101.100. Source port will be 443. Destination port will be 1025. And in the response of SYN, TCP flag will be SYN plus acknowledgement. This kind of reply will be sent from client to firewall. Now, firewall will match reply packet information with its table, like 102, 102 is going to 101, 101. Yes, layer 3 information is matching. 102 dynamic code port number 443, 443 is going to 1025, 1025. Port numbers are also matching. Now, next is what? Next we have flag. Client has sent which packet? SYN flag. Now who is coming? SYN plus ACK. In the response of SYN, SYN plus ACK is coming, or SYN plus ACK will only accept if client has initiated SYN. Yes, SYN packet was sent by client. Server is sending SYN plus ACK. Now flags are also matching. If the reply packet information L3, L4 and flag will match, the packet or traffic will be allowed. This packet will be allowed. If anything will not match, then firewall will drop this packet. So this task, or in this way, your stateful firewall works. Whatever I have told you with the help of diagram, same thing is mentioned here, that when we talk about stateful firewall maintain the state of connection when packet is traveling through the appliance. Yes, according to diagram, when client will send the packet to firewall, that packet will travel to the firewall. Firewall will create a database like layer 3 information, layer 4 information and flag. After adding information, firewall will send the packet to destination. Destination will give reply. When reply will come back, firewall will match reply packets information with table. If layer 3, layer 4 flag, they will match, packet will be allowed. Otherwise, packet will be deny. So same thing is mentioned here, that stateful firewall maintain the state of connection when packet is traveling through the appliance. Stateful firewall maintain the state of connection in state table. After adding information in state table, stateful firewall forwards the packet to actual destination. When stateful firewall receives the reply packet, firewall match the reply packet information to its state table. If reply packet match, packet is accepted, otherwise packet is dropped here. This state table is called with different name like state table, connection table, and session table. It contents are like it can contain source IP, destination IP, source port, destination port, and additional information like sin plus ACK and ACK. Such kind of information can be stored or present in state table, connection table, or in session table. So this is our third category of firewall. Next, we have here transparent firewall. So what is transparent firewall? Let's also understand it with the help of diagram. We have a network here where we have PC, we have servers. They are connected with switch. Switch is connected with router. Router is connected with, can be connected with lease line to router 2. There can be connectivity between branches with the help of MPLS VPN. There can be connectivity between branches with the help of internet. Now we have connected here router. At router, we will do IP addressing. We will do here routing. We will do here netting. We will configure here MPLS, etc., etc. Now we want to secure our network. To secure our network, we need to replace router with firewall. When we are replacing router with firewall, we need to configure IP addressing, routing, netting. Again, MPLS is not applicable. Then we will configure here firewall policies. When we are replacing router with firewall, we need to configure our entire network again. But we don't want to configure our network again. We simply want here only firewall policy. Is there any solution? Yes. If our task is only firewall policies, then we can deploy here transparent firewall. Transparent firewall is connected between lane and gateway. Break the connectivity between gateway and lane. Now we have here firewall. At this firewall, we will deploy the firewall policy. So without changing network, still we can deploy firewall policies with the help of transparent firewall. Now, same thing you will learn here, that when we are talking about transparent firewall, it works at layer 2. Yes, here it will act like switch with two interface, port number 1 and port number 2. If the traffic will arrive at port number 1, that will be forwarded via port number 2. When any reply will receive at port number 2, that will be forwarded at port number 1 according to the policies. Now, transparent firewall, it works at layer 2, or it forwards the frame based on destination MAC. But still, it has capabilities to filter the traffic from layer 2 to layer 7. In other vendors, this functionality is available with same name or different name like virtual wire. Some vendor provides L2 deployment with transparent firewall. Some provide with virtual wire. What is the advantage of transparent firewall? You can deploy transparent firewall in your network if you want to implement firewall in your network without readdressing the surrounding device or without redesign your network. If you don't want to reconfigure devices again, if you don't want to redesign your network again, but still you want to implement firewall or firewall policies, you can use transparent firewall here. So this was something about transparent firewall. Okay. Now, till
I,
now we have learned,
I have
yes.
a doubt actually. Can I ask?
Hmm.
Okay,
Yes.
so suppose this work is on layer 2. So layer 2 configuration we can do also in the router now. So what is the advantage of we have putting a firewall over there?
Which kind of layer 2 configuration you can do on router? Can you tell me?
You mean
What do you mean by layer 2 configuration on router?
okay? So MAC address filtering.
Are you sure? Can
So
you
sorry,
do
sorry,
Mac?
but no. Sorry, sorry. I understood actually. Okay, but if we are implementing a firewall, we are expecting a layer 7 of at least that type of inspection. So is there any advantage of putting that thing over?
Whatever I have told you with the help of diagram, are you not getting my point? It's too much undo I can't do here. The it is not. Main point is this. I want to deploy a firewall in my network, but
Okay,
there is one condition. I don't want to do any kind of change in my network. Are you getting my point?
got.
I want to deploy a firewall in my network, but condition is this, I will not modify anything. There will be no modification in diagram. There will be no modification in the configuration on lane side or gateway side. So do we have any solution? Can we deploy firewall? Yes. In that condition, you or we can use transparent firewall.
Okay,
Now,
got.
what about filtering? Yes, filtering capability you can deploy from layer 2 to layer 7 filtering or inspection still you can configure. Clear?
Yeah, understood.
So till now we have learned about firewall, what is firewall and firewall techniques like packet filtering, proxy server, stateful firewall and transparent firewall. Next firewall technique is here. Next generation firewall. This is also called sandbox inspection, or it is also called reputation based firewall. Clear? Next remaining firewall technique is here. Next generation firewall, which is called sandbox inspection. Some people call it reputation based firewall. Let's understand it with the help of diagram. We have a PC connected with switch. Switch is connected with firewall. Firewall is connected with internet. Internet is connected with public server. Okay, so first of all, we will take the example of normal firewall. At normal firewall, we define rules like non-applications, applications, and action. Non-applications like telnet, SSH, HTTP, HTTPS, FTP, SMTP, etc. If application is known, then we will allow it, as well as we will also create here another rule like non-attacks action deny. To identify non-attacks, definitely we will enable here signatures. To understand signatures, we can simple use here different colors. Like if this kind of pattern available in the data, then we can consider them as attack and we will deny them. Now we have a user sitting on PC. This user is sending request to public server. Either it is HTTP or HTTPS. First of all, we are understanding, yes, we are hitting to HTTP server. So request will go to public server. Now public server will give reply. In reply, this server will send data, or you can call it reply. When this reply will come at firewall, then firewall will match this reply with known applications and known signatures. Because communication is going over port number 80 and port number 80 means HTTP communication is allowed, then this data or reply will be here allow. Simple. If client is sending any request to any server, server is giving reply, then this reply will be matched with non-application and non-attacks. Now reply is matching with non-application, then it will be allow here. But what will happen if this reply contain any kind of attack? Now this reply or data has some attack, and for attack we have used here signatures. Now you can see here when reply or data is coming, then firewall will check here. Firewall will check here. Third step, it will check known applications and non-application and non-attacks. Now data is belonging to HTTP, but it contain attack, non-attack signatures. And what to do now? This communication will be denied. Now firewall will deny this reply. Firewall will not allow it. So what we are getting here? We are getting or coming at this point when we are talking about normal firewall. At normal firewall, we will define non-applications and non-attacks. If traffic or reply is matching with non-application and it has no attack, we will allow it. If reply matching with non-application as well as non-attack, we will deny it. So normal firewall will allow non-app and normal firewall will deny non-attack. What will happen if this data contain or if this data has a non-attack? So let's assume that this data contain here 0-day attack or unknown attack. 0 ZDA, 0-day attack, or we will also call it unknown attack. Now reply is coming at firewall. Firewall will check, okay, the data belongs to application HTTP, but it is not matching with any signature. If it is not matching with any non-attack, then what will happen in fourth step? In fourth step, this data with 0-day attack will be allow here. When this 0-day attack will go to host, host will be compromised. Now, what is the drawback of normal firewall? Normal firewall can only deny non-attack, but it will allow unknown attack. Now, do we have any solution using which we can protect our network from ZDA? Yes, we have a solution, and that is called sandbox inspection. In sandbox inspection, we configure a rule like this. If attack is unknown, if attack belongs to unknown, then take this action, send information to cloud or data center of firewall. If this firewall belongs to Fortinet, it will send to the data center of Fortinet. Same Palo Alto firewall will send information to Palo Alto. Checkpoint firewall will send information to Checkpoint data center or appliance, or Fortinet will send to Fortinet appliance or data center. Now, this internet will be connected with the data center of either you are using Palo Alto, FortiGate, Checkpoint, or Cisco data center, or we can say cloud. Now, this is the responsibility of firewall. This firewall will send the information to the data center or cloud of firewall vendor, and at that cloud they have hired engineers, so there will be engineers in their organization. Now let's start. Now firewall is getting reply. Firewall will match this reply with known applications. It will match, but it is not matching with known attacks. Okay, so data, whenever firewall will receive data, firewall knows, okay, it is matching with known application HTTP, but it is not matching with non-attack. But along, instead of non-attack, it is also matching with abnormal pattern. So it also contains some unknown attack or unknown information. If it is matching, firewall will still allow it, but along with it, additionally, the firewall will send information to cloud that I have a data, and that data contain such kind of pattern which is unknown for me. Then this will go to the cloud or data center of the firewall vendor. Now when this information will be uploaded or sent, so this file will be uploaded to the cloud. This file will be uploaded to the cloud portal or vendor portal. At that portal or at that server or at in that appliance, this appliance can be locally. So we are talking here about the perspective of cloud. So the firewall will send information to public cloud. When this will go to in their system, they have hired engineers. They will analyze it that whatever we have received, this is attack, and for that attack what they will generate, they will generate here solution, or they will also generate, or you can call signature. That signature update will be generated by them or their engineers or their expert. Now after generating signature or solution, they will generate update. Done. After generating solution, that solution will be encapsulated or will be crafted as an update, and that update will be delivered to your firewall. Now firewall will accept this update as well as this signature, which belongs to non-attack. In this way, now firewall will accept this update as a non-attack. Now we can see here the attack which was previously unknown for us, now that is known for us. But this process of unknown and known will take time. So what vendors say about it? If you have sent any file to us, we will send update. There is a time window. There is a time window between file sending and update receiving. This time window is normally 3 to 5 minutes. All vendor says that if you have sent any file to us, we will send update to you within 3 to 5 minutes, but there are some term and condition. But forget about it. So vendor will send the update to our firewall and our firewall will accept that update. Now we can see that zero-day attack is now known for us. Now, what will happen between this period? So we can say here before update, before update, ZDA will be allowed. Before update, ZDA will be allowed. But now we have update. After update, ZDA will be denied. After update, zero-day attack will be denied. This capability of sandbox inspection is only available in next generation firewall. So what is next generation firewall? Or before next generation firewall, what is normal firewall? So we can say here when we are talking about normal firewall will allow non-applications, but it will deny non-attack. But it can't stop a non-attack. Then what next generation firewall can do? Next generation firewall will allow non-applications. It will deny non-attacks, but it will send unknown attack information to cloud, and whatever update offered to the cloud, the firewall will accept that update and it will start to protect your organization according to the update. So any device which has, or any firewall which has sandbox inspection capability, that is called next generation firewall. Then what is sandbox inspection? Sandbox inspection is a process in which a device sends a file or data to a dedicated system for deeper inspection. And whatever the solution offered by the dedicated system, firewall will accept, device will accept it, and it will start to protect your organization according to the updates. So any device which has sandbox inspection capability, that is called next generation firewall. Next generation firewall has capability that it can deny non-attacks. But along with denying non-attack, it can send a non-attack information to cloud so that cloud can give the updates about unknown attack, and when firewall has update, then it will start protect your organization. So this is your sandbox inspection. This capability can be in the firewall, that will be called next generation firewall. This capability can be in the IPS, that will be called next generation IPS. Now, how many vendors firewalls support sandbox inspection? Palo Alto firewall supports sandbox inspection. FortiGate firewall supports sandbox inspection. Checkpoint firewall support sandbox inspection. Cisco FTD also support sandbox inspection. So any device which has sandbox inspection capability, that is called your next generation firewall. Any question? Okay. So this was our fifth. Yes, Jaishankar.
Yeah, sir, I do have a question. Like, suppose we are using a FortiGate firewall.
Mhm.
We got a new zero-day attack, and the signature will be updated.
Mm.
So, in one organization, it will be updated that signature. So, if the other other organization is using Palo Alto or some, whether how do they update this signature in other firewalls as well? If
So
the
listen here. Actually, these signatures are proprietary. Got it or not? FortiGate will
Mm,
never send
got
its update to Palo Alto. Palo Alto
it.
will never share this update to another vendor. Because if they are sharing their database, then why we need to purchase another vendor device or another vendor solutions? So this solution only belongs to same vendor. Now look here, if for example this device belongs to FortiGate. So FortiGate firewall will send to FortiGate cloud. Now, the FortiGate has a new zero-day attack information. Assume you are another customer here and you also belongs to your firewall also belongs to FortiGate, and you have sandbox inspection subscription also here. Now FortiGate will send that update to you as well, but condition is this update will go to same vendor which have sandbox inspection subscription enable, but these update will never go to cross vendor. Got it? So this was something about sandbox inspection or next generation firewall. So what we have covered today? Today we have covered what is firewall and firewall techniques like packet filtering, proxy server, stateful firewall, and transparent firewall and next generation firewall. Today we will keep only this. Tomorrow we will start with next topic. See you tomorrow.